If you picture a rifle, you probably picture a completely rigid, static metal tube.
Right, yeah, like a frozen pipe or something.
Exactly. You aim that tube,
Right.
you pull the trigger, and a bullet travels perfectly down this completely motionless tunnel. But the reality is actually a violent, invisible chaos.
Oh, absolutely. It's incredibly violent.
Yeah, because when a round is fired, that steel barrel physically whips and bends. It's like a struck tuning fork. The physics are absolutely wild, and we're going to see how the exact placement of your hand on the gun can completely change where a bullet goes.
And it's not because of some tactical fashion trend you saw online.
Right. It's pure, undeniable mechanical science. Welcome to today's deep dive, everyone. We are digging into an incredibly detailed article by firearms instructor Herfel from ValorTech. It's titled AR-15 Barrel Harmonics and Support Hand Control.
It's a fantastic piece of writing because it just totally shatters that entire illusion of the motionless firearm.
It really does. And our mission for this deep dive is to explore that. Whether you are, a seasoned shooter who hits the range every weekend, or just someone who's insanely curious about the physics of energy transfer, this is going to fundamentally change how you visualize a projectile leaving a barrel.
We are definitely going far beyond just the spark and the bang today.
For sure. So let's slow down that fraction of a second when you actually press the trigger.
Yeah.
It's a sequence of extreme violence, right?
Yeah, extreme violence is the perfect way to phrase it. The primer ignites the propellant, and that creates tens of thousands of pounds of pressure per square inch.
Oh, wow.
And that rapidly expanding gas physically forces the copper jacket of the bullet to engrave into the steel rifling grooves of the barrel.
So right away, you have this massive friction and acceleration.
Right. And as the bullet is forced down the bore, Newton's third law kicks in, and the rifle begins its rearward recoil impulse.
Okay, let's unpack this. Because it's not just the bullet moving forward. There's an entire cascade of mechanical actions happening simultaneously.
Exactly. Specifically, in an AR-15 or, an M4-style carbine, high-pressure gas is actually siphoned off through a tiny hole in the barrel before the bullet even leaves.
Wait, while it's still in the barrel.
Yep. That gas travels back through a tube to slam the heavy internal metal parts, the bolt carrier group, violently backward to cycle the next round. And then, at the very end of this entire chain, your body has to absorb and redirect all of that kinetic energy.
So with all those heavy metal parts slamming back and forth and literally an explosion happening inside a steel tube, the metal itself physically reacts.
It has to. It vibrates. The terminology varies depending on if you're talking to a physicist, an engineer, or a ballistician.
Right. I've heard a few different terms for it.
Yeah, you'll hear it called barrel whip, barrel harmonics, muzzle oscillation, or resonant vibration. But the physical reality is exactly the same. The barrel moves.
And it's not just a simple up and down movement either.
No, it's a highly complex movement. It flexes vertically, horizontally. It can move rotationally or angularly in this chaotic microscopic dance.
It's honestly kind of mind-blowing when you think about it. It's like striking a tuning fork that is also simultaneously trying to contain the miniature explosion. The metal has to ring.
It has to flex because all that mechanical energy has to go somewhere. If you look at it through the lens of engineering, a standard 16-inch AR-15 barrel acts exactly like a cantilever beam.
Like a diving board.
Perfect analogy, yeah. Imagine a diving board. It's anchored firmly at one end where the barrel meets the upper receiver of the rifle, and the other end, the muzzle, is completely free-floating, just suspended in space.
Right.
When that cartridge fires, the chemical energy from the gunpowder instantly becomes mechanical energy.
So that energy is doing a lot more than just pushing a piece of lead and copper out of the front.
Oh, so much more. It drives the bullet, but it also creates intense heat. It produces a deafening sound wave. It cycles the action. It pushes the entire rifle backward into your shoulder. And crucially, it deforms and vibrates that cantilever beam.
The barrel absorbs part of that explosive energy and rings.
Yes, physically whipping the muzzle end around in space.
But, and this is what I keep getting stuck on, if this metal tube is actually whipping around in all these different directions while the bullet is still traveling down it, how do you ever actually hit what you're aiming at?
Well, it all comes down to one singular microscopic instant in time.
Okay.
The initial flight path of the bullet is decided by one thing only, and that's the exact position and condition of the muzzle at the absolute fraction of a second. The base of the bullet exits the crown of the barrel.
The very last physical boundary.
Exactly that.
Yeah.
While the bullet is inside the bore, the barrel dictates everything. But the second the bullet clears the muzzle, The rifle's job is over. It is entirely finished.
So if you have, say, a perfectly machined chamber, and you've spent $3,000 on a super high-end
Like a
optic,
great optic.
but the muzzle happens to be vibrating slightly to the left at the exact millisecond the bullet leaves, the bullet goes left, it just doesn't care about your expensive scope.
It doesn't care about the scope, the chamber, or how confident you felt when you pulled the trigger. The bullet brutally and honestly records whatever the muzzle was doing at that precise moment.
Because from the instant of exit, external ballistics completely take over.
And those external forces are highly unforgiving. You have gravity pulling the bullet down immediately. You have aerodynamic drag slowing it down.
Crosswinds pushing it around.
Right, crosswinds pushing it laterally. You have the gyroscopic spin stability imparted by the rifling, and you have yaw, which is the bullet's tendency to wobble slightly before it stabilizes in the air.
So any mistake at the muzzle gets amplified.
Exponentially. If the muzzle was angled even a fraction of a millimeter off-center during its vibration cycle at the moment of exit, those external forces grab that tiny deviation and magnify it over distance. A microscopic shift at the muzzle means missing your target entirely at 300 yards.
Wait, so if the muzzle moving around is the root cause of the bullet going off target, shouldn't our ultimate goal be to just clamp the barrel down entirely?
Clamp it down.
Yeah, like brace it against something totally solid, stop the vibration, and just make it stay perfectly still.
I mean, it seems like the obvious solution, but it fundamentally defies the laws of physics. You simply cannot stop the vibration.
Really? Even if you brace it?
Even then, the energy transfer is too violent, the heat expansion is too severe, and the structural reality of a cantilever beam practically guarantees it will flex. This brings us to a golden rule of barrel harmonics from the article.
Let's hear it.
Accuracy is not the absence of vibration. Accuracy is repeatable vibration.
Okay, let me make sure I'm wrapping my head around this. The problem isn't that the steel barrel is whipping around like a tuning fork. The problem is if it whips around differently from shot number 1 to shot number 2.
That is the crucial distinction. If the barrel vibrates the exact same way through the exact same arc every single time you fire, then the muzzle will be in the exact same microscopic position at the moment the bullet exits.
And if the muzzle is in the same position?
The bullet takes the same path and impacts the exact same spot on the target. The barrel doesn't need to be perfectly still to be accurate. It only needs to be perfectly consistent.
Okay, so if repeatable vibration is the holy grail of accuracy, how on earth do you guarantee that a violent explosion flexes a piece of metal the exact same way every time?
You have to start viewing the rifle not just as a tube launching a projectile, but as a coupled mechanical system. Every single part interacts.
Like what parts specifically?
The barrel, the upper receiver, the gas system, the handguard wrapped around the barrel, the sling, the surface you might be resting the gun on, and most importantly, your own body.
How you physically interact with the rifle dictates how it manages that energy.
Exactly.
Which brings us right into the debate over the support hand. If you spend 5 minutes looking at shooting forums or training videos online, you will see people arguing endlessly about where to put their non-dominant hand on the front of the rifle.
Oh, constantly.
And a lot of them treat it like a purely aesthetic choice, like they're just picking out the color of their shoes or something.
Treating hand placement as a fashion statement completely ignores the mechanical reality of the machine. Your support hand is not a decorative accessory. It is your primary control interface.
Okay.
And to understand why its placement matters, we have to talk about leverage and torque.
The law of torque.
Yeah.
Force multiplied by the distance from the pivot point.
Right. Think about your shoulder, where the buttstock rests as the pivot point. The rifle extends out in front of you.
Yeah.
If you grip the rifle really far to the rear, bringing your support hand all the way back against the magazine, well, you are minimizing the distance from the pivot point. You are giving up almost all of your mechanical leverage over the front end of the rifle.
It essentially turns the barrel into a long, uncontrolled lever just waving around in space.
Exactly. Even if holding it close to your body feels more comfortable or less tiring for your arm.
But comfort does not equal performance.
It really doesn't. If you have no leverage, you cannot effectively control the mechanical energy of the firing cycle. The muzzle is going to rise violently, and the rifle is going to drift laterally.
But when you move your hand forward,
when you slide that support hand further forward toward the muzzle, you drastically increase the distance from the pivot point. You give yourself mechanical authority over the system.
Here's where it gets really interesting, because you can visualize this with something completely mundane.
Like what?
Think about trying to sweep a heavy pile of wet dirt
Mm-hmm.
with a push broom.
Okay, I can picture that.
If you hold the broom handle all the way at the very top, close to your chest, that heavy dirt is just going to push the broom head all over the place. You have zero leverage.
You're just fighting it.
Exactly. But if you reach your hand halfway down the handle, closer to the bristles, suddenly you can drive that broom head exactly where you want it. The handguard of the rifle is the broom handle.
That broom analogy perfectly captures the physics at play. By reaching forward, you apply torque efficiently. You gain the authority to actively drive the gun.
So it's not just about keeping it steady.
Right. A forward grip controls muzzle rise, it stops lateral drift, and it makes transitioning between multiple targets far crisper.
And recoil recovery.
It radically improves recoil recovery, meaning your ability to let the gun cycle absorb the energy and have the muzzle snap back to the exact same visual index point on your target so you can fire again.
But hang on a second. I am seeing a massive contradiction here, based on what we just talked about.
What's the contradiction?
Well, if I reach way out to the front of the rifle to get all this incredible broom handle leverage, and I grip the front of the gun really aggressively to control that violent recoil, aren't I going to totally mess up that delicate, repeatable vibration of the barrel?
That's a great question.
Because I'm basically squeezing the very thing I'm supposed to let vibrate naturally, right?
That is the exact trap many shooters fall into, and it highlights the most critical mechanical boundary on a modern rifle. You must aggressively control the handguard, but you must absolutely never load the barrel.
So you have to isolate the control forces from the harmonic forces.
Yes, and this is the entire engineering reason behind the invention of the free-float handguard.
How does that work?
Well, in older rifle designs, the handguard, the part you hold, was often physically clamped directly onto the barrel itself. So any pressure from your hand or your sling pushed directly against the steel tube.
Right, messing with the tuning fork.
Exactly. But a free-float handguard is a rigid aluminum tube that attaches only to the receiver of the rifle. It extends out and completely encases the barrel, but it never actually touches it.
Oh, wow. So it creates a physical shell around it.
Basically, yeah.
You can clamp down on the outside of that aluminum shell, torque it, drive it, and put all your body weight into controlling the recoil, but the actual steel barrel inside is floating in empty space, totally uninterrupted, doing its consistent tuning fork dance.
Precisely. You get the mechanical leverage over the system without interrupting the resonant frequency of the barrel. But if you breach that boundary, if you apply direct physical pressure to the barrel itself, you instantly change its natural frequency.
Give me a real-world example of how someone accidentally does that.
Imagine you're shooting from behind a wooden barricade. You want to be stable, so you rest the front of your rifle on the wood.
Seems normal enough.
But instead of resting the handguard on the wood, you push the barrel itself down onto the barricade. By applying that upward physical force against the steel, you are preloading the cantilever beam. You've bent it microscopically before you even pull the trigger.
And when it fires.
When the gun fires, the harmonic wave hits that physical pressure point, the vibration pattern changes, the muzzle exits the cycle at a different angle, and your bullet misses the target entirely.
And the same thing would happen if you had a sling bolted directly to the barrel and you wrapped it tightly around your arm, right? You're pulling the tuning fork out of alignment.
You are. And physical pressure is just one variable. The article lists numerous disturbance factors that can alter that delicate resonance.
What else changes it?
Well, what happens when the barrel gets incredibly hot after firing 30 rounds? The metal expands, the structural properties shift slightly, and the vibration frequency changes.
So a cold barrel and a hot barrel literally ring differently.
They absolutely do. Or what happens if you attach a heavy metal sound suppressor to the muzzle? You've just added a massive weight to the completely unsupported end of your diving board.
It's like taping a roll of quarters to the end of a tuning fork. It's going to vibrate way slower and at a totally different pitch.
Exactly. Changing ammunition changes the pressure impulse. Adjusting the gas block changes how hard the internal parts slam backward. All of these inject new variables into the vibration pattern.
There is a quote from the source material on this that I absolutely love. It says, "Pressing on the barrel is negligence wearing tactical gloves."
That's such a great line.
It's hilarious, but it completely reorients how you think about missing a shot. You might have a shooter who misses a target at 200 yards, gets incredibly frustrated, and immediately starts twisting the dials on their expensive optic, blaming the scope.
Happens all the time.
When in reality, they just squish their barrel against a plastic barricade, changed the physics of the system, and the rifle did exactly what it was mechanically forced to do.
Because the rifle never betrays the shooter, it simply obeys physics. The shooter introduced a mechanical inconsistency by changing the structural forces from shot 1 to shot 2.
Which brings a harsh reality to light regarding how we train and instruct people on firearms.
Right, because if controlling the rifle is a matter of strict physics and leverage, it completely destroys the idea that how you hold the gun is just personal preference.
Yeah, you hear that phrase thrown around a lot.
You do. There is a fantastic line in the author's analysis that addresses instructors who wave away hand placement as subjective. He states that personal preference is what someone puts on a sandwich.
That's brilliant.
Rifle control, on the other hand, is an engineering problem. You don't get to have a personal preference about gravity, and you certainly don't get to have a personal preference about the mathematical realities of torque.
You can't just choose to defy physics because holding the magazine well feels cozier on your bicep.
If you do, you trigger a sequential chain of failure. Let's trace it back.
Okay.
It starts with inconsistent hand placement. Because you aren't using the full length of the handguard to maximize leverage, your grip changes slightly under recoil.
Right.
That inconsistent hand placement leads to inconsistent pressure applied to the rifle system. Inconsistent pressure allows the mechanical energy of the firing cycle to move the gun erratically, resulting in inconsistent muzzle behavior.
And as we established earlier, inconsistent muzzle behavior guarantees an inconsistent impact on the target.
Exactly.
So what does this all mean? For you listening, it means that point of aim and point of impact are not magical concepts. They aren't held together by hope or luck or how much money you spent on your gear. They are dictated entirely by repeatable mechanics.
And you cannot validate those mechanics unless you subject them to realistic testing standards.
Meaning you can't just bench test it.
Right. You can't just sit comfortably at a concrete bench. Rest your rifle on a perfectly stable sandbag, fire 3 shots, declare the rifle zeroed, and assume that point of impact will remain identical when you're standing up.
Because sitting at a bench is an artificial environment. The rifle is resting in a very specific, perfectly repeatable way that you will never replicate in the real world.
When you move from a bench to a standing position, the way your body absorbs the recoil changes entirely. The fulcrum shifts.
What about going prone?
If you drop into a prone position and rest the magazine on the dirt, the upward pressure into the receiver changes the system's harmonics.
So testing your point of impact across different physical conditions isn't just about practicing your stance, it's about checking the physics of the rifle in those specific shapes.
Precisely. You have to understand how the system behaves when it's supported by a barricade versus freestanding. You have to know where the bullet impacts when the barrel is freezing cold versus when it's burning hot.
With the suppressor and without it.
Right. Suppressed and unsuppressed. Sling-loaded or not. Training that doesn't account for these mechanical shifts is just administrative comfort disguised as capability.
This entire breakdown has been such a massive shift in perspective. To summarize the journey we've taken today for you listening, we have to completely abandon the illusion of the static metal tube.
Absolutely.
We now know that a rifle is a violently dynamic, interconnected mechanical system. When you fire, that steel barrel physically rings and flexes, and we know that the bullet's entire external flight path is dictated by the microscopic position of the muzzle at the exact fraction of a second it exits.
That single moment is everything.
Yeah. And the profound takeaway here is that we achieve true accuracy not by trying to awkwardly clamp down and stop that violent vibration, but by allowing it to be perfectly repeatable. We manage that energy by maximizing our forward leverage on a free-floated handguard, essentially letting the barrel float in empty space to do its mechanical dance uninterrupted.
It is just a brilliant example of human biomechanics interfacing with raw engineering.
It really is.
And to leave you with one final thought to mull over, consider the profound sensitivity of this entire harmonic system we've been talking about.
Okay, I'm intrigued.
If every tiny external variable, from a hot barrel to the microscopic upward pressure of resting a handguard on the plastic barricade, visibly alters the resonant vibration at the muzzle, it really makes you wonder.
Wonder what?
How much does the microtension in your own muscles, which subtly changes depending on your stress level, your physical fatigue, or even how much coffee you drank that morning, secretly rewrite the physics of your shot before your finger even touches the trigger?
Oh man, that is a terrifying and utterly fascinating thought.
Thank you.
Just how much our own internal biology is secretly steering the external physics of the machine. Thank you so much for joining us on this deep dive. Keep questioning the mechanics of the world around you, keep looking past the static illusions, and we will see you next time.